All right, welcome to a important video on my channel, one that is a bit overdue. AWS recently had a massive outage, um, just uh, just massive. So it would be a issue if I didn't go over that in this channel. That's exactly what this channel is all about. In the past, I've covered there was a massive outage by uh, uh, Facebook, also known as Meta. Um, so uh, so yeah, let's read about the outage. We'll try to stick to official channels. So here we go. So I think this is probably a good one. This was issued on October 22nd, 2005. And this about Amazon.com looks official to me. Um, yeah, so it was written by the Amazon staff. So let's go right to the source. Between 11:49 p.m. Pacific time, my time that would be one near 2 o'clock on October 19th, and 2:24 specific daylight time on October 20th. AWS experienced increased error rates for AWS services in the US-EAST-1 region, which also impacted Amazon.com and Amazon subsidiaries, as well as AWS support operations. By 12:26 a.m. PDT on October 20, we determined that the event was the result of DNS resolution issues for the regional DynamoDB uh, service endpoints and mitigated the issue by 2:24 a.m. PDT. So let's take a brief pause here and figure out how long it took them to determine it and then to resolve it. So they determined it around 12:30, and then they resolved it around so they determined it around 12:30 a.m. on the 20th, and then they resolved it um, about 2 hours later. So two around 2:30. So it took them um, after they realized that it was the result of DNS resolution issues for the regional DynamoDB service endpoints. It took them 2 hours to mitigate it. But prior to that, um, let's see here. It took them. Oh wow. Okay, this is interesting. It actually took them. Oh, I see. Okay, yeah. So prior to that. It looks like it took them about 12 hours to determine what the cause was. So we can see on October 19th, um, so 11:49 p.m., super late at night, 2 a.m. my time. So we're just going to call this midnight. Um, uh, there were increased error rates. Um, so it wasn't until the next day around midnight, about a 24-hour span, that they determined the event was the result of DNS resolution issues for the regional Dynamo DB service endpoints. So there you go. If you're a fan of this channel, um, and you want a payday from Amazon for how good you are at an expert, as a technical expert, and how much value you can bring, cut this in half. Say, okay, you detected that there were problems midnight, October 19th, um, and then you figured out what the problems were 24 hours later. Hire me, buy my services. That's going to be 12 hours. Get a huge payday from that. And I think I think there's a million ways you could do that. Yeah, after resolving, so you're not going to get much leverage. I mean, it took them 2 hours to solve it. So yeah, if you could put that down to like an hour, they'd probably be interested in that. But this is the thing that jumps off the page to me immediately. It took them 24 hours to even know what the heck was going on. Unacceptable. Cut that in half, get a big you'll yeah, cut that in half. After resolving the DynamoDB DNS issue, AWS services began recovering, but a small subset of internal subsystems continued to be impaired. To facilitate full recovery, we temporarily throttled some impaired operations, such as EC2 instance launches. So this channel has mostly focused on kind of like traditional network engineering. We have gone into some cloud stuff. I'm just gonna uh, I do know some stuff. So this stands for Elastic Compute. This is basically like a virtual machine you can buy from Amazon that you can pay for on pricing tiers for how powerful you want it. So instead of going to like Best Buy or like a going to Amazon and buying an actual computer that they ship to your house, you can use the whatever computer you already have to access uh, remotely a computer owned by Amazon here, and you can adjust how much you want to pay based on how much how powerful you want that computer to be, and you can actually even have it be lowered or raised depending on what your budget looks like that month. So that's really the power of cloud is pay as you go pricing. If you have reduced needs one month, you pay less. Higher needs another month, you pay more. Otherwise, you got to buy everything up front. You got to do all the math, and if you didn't hit the math exactly right, you're either going to pay too much for gear that you don't use, or even worse, you're going to pay too little. And when you really have those big traffic spikes, like you're selling a lot of stuff, a lot of people are coming to your site, your services go down. No good. It'd be much better just to um, fork over, a percentage of those increased sales and keep your services running. By 12:28 p.m. PDT, I'm not sure what day this is. I'm guessing it's the 20th. Yeah, because it looks like midnight. They determined that after 24 hours, they determined it had to do with DNS resolution issues. And then in about 2 hours, they resolved it. So it looks like then at noon the next day, noon on the same day on the 20th, many AWS customers and AWS services were seeing significant recovery. We continued to reduce throttling of EC2 new instance loss operations, and I'll do a sound check here. Looks good. While we worked to mitigate the remaining impact. By 3:01 PDT, so about more like 2.5 hours later on the same day, the 20th, all AWS services returned to normal operations. Customers should continue to refer to the AWS Health dashboard for the latest information. So this is great. Um, this is probably the best source if you're just watching the news or like something like that, and you're a subscriber to this channel. Get into the weeds. That's probably not going to go in depth enough. So, speaking of which, we'll go to the health status. We can and let's focus on the things that were affected. So we know that US East 1 was affected. Let's see if that shows up on this. We'll yeah. So we're gonna okay. So we got the region here. So let's see how that shows up. Um, okay, so we just got services running in that region, it looks like. So kind of, yeah. So we just got services running in that issue region. Let's go back in time, and we know that the outage happened on the 19th and the 20th. So let's get that showing up on the dashboard and see if we can um, see the status change here. So we're gonna go here. We're gonna go back to the 19th, Let's go back even further than that to the 17th. Oh, actually, no, let's go. So they resolved it here, so we're going to go Friday the 24th. There we go. This is perfect. And now we can see here's the Friday, Thursday, Wednesday, Tuesday, the Monday where they solve things, and then the Sunday, of course, when it happened. So we can see lots of changes and what is this? This is a yeah. So lots of things that were impacted, lots of impacted services on the 20th. Um, so it's interesting that they saw them on the 19th because well, let's see the time. So here's a AWS Direct Connect that was affected on the 20th. So there were increased error rates and latencies. So it started at about midnight on the 20th, and then yeah, it started about midnight on the 20th. So here's their log. Um, yep, and then when was it resolved? Well, they've got ongoing monitoring, but it's all here. It's all here. So yeah, this was disrupted. There we go. Remember that DynamoDB that was called out in the official report. So this is the best place to go. Beyond that, I'm not sure what this is. Oh yeah, this is the summary of the server's disruption. Yeah, I think I'm gonna read this next. Um, yeah, that's going to be important. But if you really want the most details you can get, this dashboard is probably the way to go. Let me close this here and then let's look at another region. So, US West. Yeah, here we go. US West 2. And then for the same time, we see, yeah, nothing was impacted there. It was just this US East region that was impacted, and even the U.S. East 2 wasn't impacted. Wasn't impacted. It was only the US-EAST-1 that was impacted. And I'll include links to all of this in the description to this video, but we can see um, all the things that were impacted here. It impacted API gateway, it impacted AppFlow, AppStream, Athena. It didn't impact everything, which is interesting. So the augmented AI stuff, it didn't impact. It also didn't impact it didn't impact quite a few services. You can kind of get a sense for how things are. And here we go. Here's the big one. Uh, DynamoDB, as was called in there, was disrupted rather than just simply impacted. So that's a much more critical thing. Before I go and read that next article, let's read everything about this. Okay, so on the 20th, um, and notice how none of this starts on the 19th. That's because they didn't know yet, right? They didn't even know that it was um, the result of like I wonder how this dashboard, this is where, take that down to from 24 to 12 hours, you got a payday coming. I think this dashboard probably needs some um, you know, because this was not started until 24 hours later. All right, so at midnight on the 20th, we are investigating increased error rates and latencies for multiple AWS services in US-EAST-1 region. We will provide another update in the next 30 to 45 minutes. Okay, so about an hour later, we can confirm increased error rates and latencies for multiple AWS services in the US-1 region. This issue may also be affecting case creation through the AWS Support Center or the Support API. We are actively engaged in working to both mitigate the issue and understand the root cause. We will provide an update in 45 minutes or sooner if we have additional information to share. So, yep, about 45 minutes later, here's their next update. We can confirm significant error rates for requests made to the DynamoDB endpoint in the US-EAST-1 region. This issue also affects other AWS services in the US-EAST-1 region as well. During this time, customers may be unable to create or update support cases. Engineers were immediately engaged and are actively working on both mitigating the issue and fully understanding the root cause. We will continue to provide updates as we have more information to share or by 2 a.m. So a little bit late here. They did it a minute later than they said. So we have identified a potential root cause for error rates for the DynamoDB APIs in the US East 1 region. Based on our investigation, the issue appears to be related to DNS resolution of the DynamoDB API endpoint in US East 1. We are working on multiple parallel paths to accelerate recovery. This issue also affects other AWS services in the US East 1 region. Global services or features that rely on US East 1 endpoints, such as IAM updates and DynamoDB global tables, may also be experiencing issues. During this time, customers may be unable to create or update support cases. We recommend customers continue to retry any failed requests. We will continue to provide updates as we have more information to share or by 2:45 a.m. So about 20 minutes later, we have applied initial mitigations, um, and we are observing early some signs um, of recovery for some of the impacted AWS services. So I want to flip over to the AI at some point and get and see try to see some examples of these initial mitigations. During this time, requests may continue to fail as we work toward full resolution. We recommend customers retry failed requests. While requests begin succeeding, there may be additional latency and some services will have a backlog of work to work through, which may take additional time to fully process. We will continue to provide updates as we have more information to share or by 3:15 a.m. So they got another update just 5 minutes later. We are seeing significant signs of recovery. Most requests should now be succeeding. We continue to work through a backlog of queued requests. We will continue to provide additional information. Half an hour later, we continue to observe recovery across most of the affected AWS services. We can confirm global services and features that rely on US East 1 have also recovered. We continue to work towards full resolution and will provide updates as we have more information to share. And then about a half an hour later, the underlying DNS issue has been fully mitigated, and most AWS service operations are succeeding normally now. Some requests may be throttled while we work toward full resolution. Additionally, some services are continuing to work through a backlog of events such as Cloud Trail and Lambda. While most operations are recovered, requests to launch new EC2 instances or services that launch EC2 instances, such as ECS, in the US East 1 region are still experiencing increased error rates. We continue to work toward full resolution. If you are still experiencing an issue resolving the DynamoDB service endpoints in US East 1, we recommend flushing your DNS caches. We will provide an update by 4:15 a.m. or sooner if we have additional information to share. All right, so 408. We are continuing to work towards full recovery for EC2 launch errors, which may manifest as an insufficient capacity error. Additionally, we continue to work toward mitigation for elevated polling delays for Lambda, specifically for Lambda event source mappings for SQS. We will provide an update by 5 a.m. We continue to fully restore new AC2 EC2 launches in the US East 1. We recommend EC2 service EC2 instance launches that are not targeted to a specific availability zone so that EC2 has flexibility in selecting the appropriate availability zone. So that's the thing to notice is like you might be reading this, and I might have thought this before I learned more about cloud services. I'd be like, well, this is it. This is why you should do everything local because uh, you're down. Well, you can use a different zone, right? There's a lot you can do to work around this. So that's your other cash cow. In my opinion, I think um, is the people that were affected by this. Hey, I know AWS. I got, a few certs, or I have some experience, or I just know it. Let me reconfigure your stuff so if the availability goes down for a specific zone, you just fall back to another one. I think you could probably do that. Um, the impairment in new EC2 launches also affects services such as RDS, ECS, and Glue. We also recommend that auto scaling groups are configured to use multiple availability zones. Yep, there we go. That's what it says. So that auto scaling can manage EC2 instance launches automatically. We are pursuing further mitigation steps to recover Lambda's polling delays for event source mappings for SQS. AWS features that depend on Lambda's SQS polling capabilities, such as organization policy updates, are also experiencing elevated processing times. We will provide an update by 5:30. So kind of bold there, um, but they got it. So we confirm that we have now recovered processing of SQS queries via Lambda event source mappings. We are now working through processing the backlog of SQS messages in Lambda queues. Okay, and I feel like I'm going to. I don't think I need to read the rest of this. There's a lot of it. Um, and the reason is because I'm going to link it. So if you're interested in it, feel free to read it yourself. There should be a direct link to this report some way, somehow. Let's see. So let's see if there is. Hopefully there is. Um, oh man, I don't see if there is. Okay. Man. Uh, there's really no direct link to it, but I need a direct link. Okay, well, that's unfortunate. There's no direct link. I probably can't fit all of this in the description. Um, maybe I can. I'll probably just text dump this whole thing in there. Okay, so so let's have a brief conversation with the AI. I like talking to the AI. So we're just gonna dump this in there and not say anything else. All right, and that's quite a bit of text to dump in, so it is going to take it a little bit of time. There we go. Uh, so this is a full incident report. Yep, summary of what happened. Okay, there we go. Um, yeah, so yeah, generate a yeah, exactly. So I'm just going to say yes. All right. So Um, Here we go. So the root cause, a DNS, not enough information. So this is what we'll start. So not enough information. Show me examples of uh, the resolution issue and the fix. And then we'll probably enable what is it, Canva? I think Canva allows it to write, or is it Figma? What's the different? These I enabled new. So Canva, oh yeah, it's a visual suite. What is Figma? Uh, Now we need Canva. So yeah, let's do Canva. All right, and let's see what it does with that. Okay, so let's unpack what it looked like at the system level and how they fixed it. So, uh, okay, so this is what it might have looked like when you DynamoDB. So database. List tables. So the tables were missing. So let me, so my own site, I use Vercel in my own personal web page. But if we go back and look at the storage that I use on Vercel, I use a Supabase database. So basically, if I look at my own database here, I experience the same sort of outage that they had, like all my tables would be gone. Like I wouldn't even be able to pull this up and like, yeah, so could not connect to the URL. So like it couldn't connect in and use any of my. I think that's probably right. Yeah, so it can't communicate with the database anymore. So here's what they likely executed. Um, System D resolve flush caches, or via AWS's internal Route 53 and resolvers. Okay, so then dig, this is a DNS command. Yep, so it's a network administration command line tool for querying DNS. Um, okay, expected response after the fix. Okay, so the response before the fix would be um, that it couldn't, yeah, it wouldn't show these. Restart dependent services, restarting them. Okay, gotcha. Yeah, yeah. Uh, Give me that, and then after I'm gonna say, put it as simply answer this question simply as you can. What happened? And I have a feeling it's not going to be satisfactory there, but we'll just do that. Okay. All right. So, uh, yeah, AI maybe not the best place to go. Let's get back to the official reports. So I just want to get through this one here, and then I think that'll be probably the end of this video. So this is the summary of Amazon DB service disruption in Northern Virginia, US East 1 region. We wanted to provide you with some additional information about the service disruption that occurred in the North Virginia, US East 1 region on October 19th and 20th, 2025. While the event started at around noon on the oh, actually around midnight on the 20th. Yeah. And ended, yeah, it started around midnight on the 20th and it ended around oh, okay. So I guess I guess it was only 12 hours where they didn't know what was going on. Okay. But still, you could probably cut that down to 6 some way somehow. There were three distinct periods of impact to customer applications. First, between 11:48 p.m. on October 19th and 2:40 a.m. on October 20th, Amazon DynamoDB experienced increased API error rates in the North Virginia US East 1 region. Second, between 5:30 a.m. and 2:01 p.m. on October 20th, Network Load Balancer (NLB) experienced increased connection errors for some load balancers in the North Virginia US East 1 region. This was caused by health check failures in the NLB fleet, which resulted in increased connection errors on some NLBs. Third, between 2:25 a.m. and 10:36 a.m. on October 20th, new EC2 instance launches failed, and while instance launches began to succeed from 10:37 a.m., some newly launched instances experienced connectivity issues, which were resolved by 1:50 p.m. DynamoDB between 11:48 p.m. PDT on October 19th and 2:40 a.m. PDT on October 20th, customers experienced increased Amazon DynamoDB API error rates in that region. During this period, customers and other AWS services with dependencies on DynamoDB were unable to establish new connections to the service. The incident was triggered by a latent defect with the service's automated um, DNS management system that caused endpoint resolution failures for DynamoDB. Many of the largest AWS services rely extensively on DNS to provide seamless scale, fault isolation and recovery, low latency, and locality. Services like DynamoDB maintain hundreds of thousands of DNS records to operate a very large heterogeneous fleet of load balancers in each region. Automation is crucial to ensuring that these DNS records are updated frequently and to add additional capacity as it becomes available, to correctly handle hardware failures, and to efficiently distribute traffic to optimize customers' experience. This automation has been designed for resilience, allowing the service to recover from a wide variety of operational issues. In addition to providing a public regional endpoint, this automation maintains additional DNS endpoints for several dynamic DB variants, including a FIPS compliant endpoint, an IPv6 endpoint, and account-specific endpoints. The root cause of this issue was a latent race condition in the DynamoDB DNS management system that resulted in an incorrect empty DNS record for the service's regional endpoint. Yep, that the automation failed to repair. So here we go. The root cause of this issue was a latent race condition. Okay, so this is it. Let's put this in the AI. Explain this. Okay. To explain this event, we need to share some details about how the DynamoDB DNS, about the DynamoDB DNS management infrastructure, or sorry, architecture, not infrastructure. The system is split across two independent components for availability reasons. The first component, the DNS planner, monitors the health and capacity of the load balancers and periodically creates a new DNS plan for each of the service's endpoints, consisting of a set of load balancers and weights. We produce a single regional DNS plan as this greatly simplifies capacity management and failure mitigation when capacity is shared across multiple endpoints. As is the case with the recently launched IPv6 endpoint and the public regional endpoint. A second component, the DNS enactor, which is designed to have minimal dependencies to allow for system recovery in any scenario, enacts DNS plans by applying the required changes in the Amazon Route 53 service. For resiliency, the DNS enactor operates redundantly and fully independently in three different availability zones. Each of these independent instances of the DNS enactor looks for new plans and attempts to update Route 53 by replacing the current plan with a new plan using a Route 53 transaction, assuring that each endpoint is updated with a consistent plan even when multiple DNS enactors attempt to update it concurrently. The race condition involves an unlikely interaction between two of the DNS enactors. Under normal operations, a DNS enactor picks up the latest plan and begins working through the service endpoints to apply this plan. This process typically completes rapidly and does an effective job of keeping DNS state freshly updated. Before it begins to apply a new plan, the DNS enactor makes a one-time check that its plan is newer than the previously applied plan. As the DNS enactor makes its way through the list of endpoints, it is possible to encounter delays as it attempts a transaction and is blocked by another DNS enactor updating the same endpoint. In these cases, the DNS enactor will retry each endpoint until the plan is successfully applied to all endpoints. Right before this event started, one DNS enactor experienced unusually high delays, needing to retry its update on several DNS endpoints. As it was slowly working through the endpoints, several other things were also happening. First, the DNS planner continued to run and produced many newer generations of plans. Second, one of the other DNS enactors then began applying one of the newer plans and rapidly progressed through all the endpoints. So this is the race condition. The timing of these events triggered the latent race condition. When the second enactor applying the newest plan completed its endpoint updates, it then invoked the plan cleanup process, which identifies plans that are significantly older than the one it just applied and deletes them. Oh, that sounds bad. At the same time that this cleanup process was invoked, the first enactor, which had been unusually delayed, applied its much older plan to the regional DDB endpoint, overriding the newer plan. The check that was made at the start of the plan application process, which ensures that the plan is newer, oh man, than the previously applied plan, was stale by this time due to the unusually high delays in enactor processing. Therefore, this did not prevent the older plan from overriding the newer plan. The second enactor's cleanup process, then deleted this older plan because it was many generations older than the plan it had just applied. Oh my God. As this plan was deleted, ooh, all IP addresses for the regional endpoint were immediately removed. Additionally, because the active plan was deleted, the system was left in an inconsistent state. Oh my God, that prevented subsequent plan updates from being applied by any DNS actors. My God, this situation ultimately required manual operator intervention to correct. Dear Lord. Well, I mean, there you have it. It's a lot of like technical, like what is a latent race condition? I mean, it seems pretty easy to understand. Like, so basically, they had something doing something that like made it seem like what it did was out of date, and then they had something like verify that things were up to date. So they were constantly like in a race condition, like one was doing one thing, and then the other was doing the other, and there was no like real there was no like you know idea of like who was supposed to be winning the race in a sense. It's so like one would do one thing, the other would do the other, and there wasn't a like a winner. There wasn't a sense of like which one was doing it right and which one was doing it wrong. So like the one that was presumably doing it right would have those like kind of out of date timestamps or like records, and then the one that did it wrong, deleting stuff that shouldn't have been deleted is to do it wrong, was convinced it was doing it right because the like all the numbers were showing that. So when this issue occurred around noon on the 20th, all systems needing to connect to DynamoDB service in US-EAST-1 region via the public endpoint immediately began experiencing DNS failures and failed to connect to DynamoDB. This included customer traffic as well as traffic from internal AWS services that rely on DynamoDB. And that makes sense because um, uh, a bunch of stuff got deleted. So what happened? Yeah, it deleted a plan. I guess I don't know what a plan is. Previously applied plan. Yeah, I don't know what a plan is, but a bunch of these plans. But basically, IP addresses for the regional endpoint were removed. So of course, yeah. Um, it, Customers with Dynamo DB global tables were able to successfully connect to and issue requests against their replica tables in other regions. But because those specific IPs were removed, um, those customers experienced prolonged replication lag to and from the replica tables in the North Virginia US East 1 region. Engineering teams for impacted AWS services were immediately engaged and began to investigate. By 12:38 a.m. on October 20th, our engineers had identified DynamoDB's DNS state as the source of the outage. By 1:15 a.m., the temporary mitigations that were applied enabled some internal services to connect to DynamoDB and repaired key internal tooling that unblocked further recovery. By 2:25 a.m., all DNS information was restored, and all global tables replicas were fully caught up by about 2:30 a.m. And I'm not sure what date this was. I think it would have been on the 20th. Yeah, on the 20th, on the 20th. Um, Customers were able to resolve the DynamoDB endpoint and establish successful connections as cached DNS records required between around 2:30 and 2:40, for about 15 minutes there. They expired in, yep. This completed recovery from the primary service disruption event. Let's go back to the AI and look closer at the timeline um, that it laid out because I'm getting a little confused about that. So yeah, so here's the timeline. Um, so detected error rates. The timeline's very unclear actually. Um, Root cause. So start on the 20th. Uh, didn't something start on the 19th? Can you just break down really clearly for me the timeline of all these events? Um, how much time was so here we go. Check my knowledge here. My understanding is that there first started being issues on the 19th, and then the the like actual troubleshooting to figure out what the issues were did not resolve until 12 hours later on the 20th. And then at that time, once they knew what was actually happening, it only took about 2 hours for them to resolve things. So is this right, or am I getting the timeline wrong? And the reason it spanned across two calendar dates is just simply because they caught it a little bit before midnight on the 19th. So really, the total amount of disruption only lasted about half a day, right? All right, so let's continue. Amazon EC2 between yep, so right before midnight on the 19th, and then yeah, so about half a day later on the 20th. Um, uh, Customers experienced increased EC2 API error rates, latencies, and instance launch failures in that region. Existing EC2 instances that had been launched prior to the start of the event remained healthy and did not experience any impact for the duration of the event. After resolving the DynamoDB DNS issue at 2:25 a.m. PDT, customers experienced to see increased errors for launches of new instances. Recovery started at 12:01 p.m. PDT, with full EC2 recovery uh, occurring at 1:50 p.m. PDT. During this period, new instance launches failed with either a request limit exceeded or insufficient capacity error. To understand what happened, we need to share some information about a few subsystems that are used for the management of EC2 instance launches, as well as for configuring network connectivity for newly launched EC2 instances. The first subsystem is Droplet Workflow Manager, DWFM, which is responsible for the management of all the underlying physical servers that are used by EC2 for the hosting of EC2 instances. We call these servers droplets. The second subsystem is Network Manager, which is responsible for the management and propagation of network state to all EC2 instances and network applications. Each DWFM, which remember stands for Droplet Workflow Manager, manages a set of droplets within each availability zone and maintains a lease for each droplet currently under management. This lease allows DWFM to track the droplet state, ensuring that all actions from the EC2 API or within the EC2 instance itself, such as shutdown or reboot operations originating from the EC2 instance operating system, result in correct state changes within the broader EC2 systems. As part of maintaining this lease, each DWFM host has to check in and complete a state check with each droplet that it manages every few minutes. So starting uh, at 12 before midnight on October 19th, these DWFM state checks began to fail as the process depends on DynamoDB and was unable to complete. While this did not affect any running EC2 instance, it did result in the droplet needing to establish a new lease with a DWFM before further instance state changes could happen for the EC2 instances it is hosting. Between 12:48 on October 19th and 2:24 a.m., so about 3 hours later on October 20th, leases between DWFM and droplets within the EC2 fleet slowly started to time out. At 2:25, oh, and there's actually quite a lot remaining here. Um, at 2:25 PD, with the recovery of the DynamoDB APIs, DWFM began to reestablish leases with droplets across the EC2 fleet. Since any droplet without an active lease is not configured a candidate for new EC2 launches, the EC2 APIs were returning insufficient capacity errors for new incoming EC2 launch requests. DWFM began the process of reestablishing leases with droplets across the EC2 fleet. However, due to the large number of droplets, efforts to establish new droplet leases took long enough that the work could not be completed before they timed out. Additional work was queued to reattempt establishing the droplet lease. At this point, DWFM had entered a state of congestive collapse and was unable to make forward progress in recovering droplet leases. Since this issue had no established operational recovery procedure, engineers took care in attempting to resolve the issue with DWFM without causing further issues. After attempting multiple mitigation steps, at 4:14 a.m., engineers throttled incoming work and began selective restarts of DWFM hosts to recover from this situation. Restarting the DWFM hosts cleared out the DWFM queries, reduced processing times, and allowed droplet leases to be established. By 5:28 a.m., DWFM had established leases with all droplets within the US-EAST-1 region, and new launches were once again starting to succeed, although many requests were still seeing request limit exceeded errors due to the request throttling that had been introduced to reduce overall request load. And I'll read down to here. I'm probably not going to read this whole thing. So network, oh, right. So two more paragraphs, and then I'll probably let's see what the clock is saying. The clock is, oh yeah, hour. Okay. When a new EC2 instance is launched, a system called Network Manager propagates the network configuration that allows the instance to communicate with other instances in the same virtual private cloud, other virtual private cloud appliances, and the internet. At 5:28 a.m. PDT, shortly after the recovery of DFM, Network Manager began propagating updated network configurations to newly launched instances and instances that had been terminated during the event. Since these network propagation events had been delayed by the issue with DWFM, a significant backlog of network state propagations needed to be processed by the network manager within the region. As a result, at 6:21 a.m., a network manager started to experience increased latencies in network propagation times as it worked to process the backlog of network state changes. While new EC2 instances could be launched successfully, they would not have the necessary network connectivity due to the delays in network state propagation. Engineers worked to reduce the load on Network Manager to address network configuration propagation times and took action to accelerate recovery. By 10:38 a.m., network configuration propagation times had returned to normal levels, and new EC2 instance launches were once again operating normally. The final step towards EC2 recovery was to fully remove the request throttles that had been put in place to reduce load in the various EC2 subsystems. As API calls and new EC2 instance launch requests stabilized at 11:23 a.m. PDT on the 20th, our engineers began relaxing request throttles as they worked towards full recovery. At 1:50 p.m., all EC2 APIs and new EC2 instance launches were operating on normally. All right, so there's one more major service that was affected. That's the network load balancer. There were other services affected as well, outlined in another paragraph. Let's just skip to the closing statement for now. We apologize for the impact this event caused our customers. While we have a strong track record of operating our services with the highest levels of availability, we know how critical our services are to our customers, their applications and end users, and their businesses. We know this event impacted many customers in significant ways. We will do everything we can to learn from this event and use it to improve our availability after our availability further. Okay, so yeah, let's not. Okay, so you know we can spend a lot of time on that. If you're really interested in this, this is I think another one um, I'm gonna link is any major outage they had goes here. So we can see that they hadn't had a major outage for more than a year. The last one, this is interesting. It actually happened in the same region. It looks like all of their major outages are happening in this region lately. That's interesting. Was is that the original? That's interesting. But yeah, I'll include multiple links. I don't know what this is. Oh yeah, forget the news articles. Don't go to the New York Post. Go right to the source. It looks like they're quite transparent. They have everything time-stamped, everything explained really well. There's multiple places you can go. So you can get like a higher level summary here, just like um, a quick update. You can get a deep dive into the technical details. You can get every little tiny thing that they announced in real time on their dashboard, and then you can even get a summary of every major outage they've had since 2011. So I'm going to include these four links on this video. I'm going to dump into the AI is generally still not very good. So I'm about 90%, but it's good for this sort of stuff. I'm about 90% of correct in what happened. So the total disruption window was about 15 hours. Um, the troubleshooting took about 12 hours. Uh, oh, I see. Okay. So why was I so wrong about that? Uh, DNS failure itself, residual cascading recovery. Oh, okay. Why was I so wrong about that? I guess so it said between um yeah, so this is the text I read to come away with that impression. What did I misread? Okay, yeah. So what I read between around midnight on the 19th. Oh, yeah, okay, I got it. So I skipped the yeah, I focused so okay. Okay, I got it. This is basically what happened. I read that it happened on the 19th and then it was resolved on the 20th. So I misinterpreted um 11:49 like basically I read it as if It happened at 11:49 p.m. on the 18th. Yeah. Okay. So that's pretty good actually. Okay, so that's actually pretty good that they determined the root cause in about 2 hours. Yeah. Yeah, I'm actually making a YouTube video right now, and I opened the video unfortunately with telling my audience that it took them 24 hours to identify the root cause, and I kind of urged people in my audience like if you want a big payday, cut it to 12, but I was completely wrong about that. It only took them 2 hours. You're not going to figure out how to cut that to 1 hour. Yeah. All right. Sorry about that, everyone. It's an hour in, so you'll never ever hear the correction to that, I'm sure. But unless you're analyzing the transcripts, which is probably what these videos will be used for. Um, but yeah, okay. Um, so let's give a so here's all the details. Here's all the specific technical details. All right, let's see what it has to say with that. I'm typically only good for an hour on these videos, so this video is going to be coming to an end very soon. I'll include these four links, so I'll get rid of everything I'm not including. Um, and then let's see here. I'll probably include a link to this conversation as well. Yeah, so it happened in a number of main periods, three main periods. The first period was about 2 hours, and that's before they knew what the root cause was. The second period is the longest period. It took them about 12 hours because there were a bunch of cascading failures. So they had to address the least timeouts from the droplet managers. Um, so they fixed that in about 2 hours. Um, oh, well, they fixed the inability of it to communicate to Dynamo database, but there's still a congestive collapse. So they throttle work and selectively restart them to clear queues. Took them about 2 hours. Then about an hour later, reestablishes all leases. What about the race condition? Oh, here it is. Yeah, so that was the very first thing. Rates up to do the race condition. Yeah, yeah, yeah. Produce an empty record. Yeah, 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 yeah. Okay. Yeah, so they figured that out pretty quick. Okay, so I mean the main root cause that caused all the cascading failures was the race condition that first started at 11:48 p.m. on the 19th. And they figured that out pretty quick. They figured that out in about what, like 3 hours? Yeah, it's just all this cascading failures was like really hard for them to figure out. Yeah, so a latent race condition between redundant DNS processes caused an older DNS plan to overwrite a newer one, and then that older plan was deleted, leaving it with the endpoint with no IPs and blocking further automatic updates requiring manual operator error. Yeah, so it bricked the automation too. Like the automation like lost the target. So it like lost the address to mail the letters to. Um, yeah, okay. So I was wrong. That's always if I can figure out that I was wrong and correct that, that's always a big a good thing. I always consider that to be a good thing. Um, so, oh, yeah. So it even wrote me an on-air correction script, so I'll read that. I initially said AWS took 24 hours to find the root cause. That's wrong. According to AWS's post-event summary, they traced it to DynamoDB DNS automation race condition within about 2 hours and restored the DNS by 2:25 a.m. Pacific Daylight Time. The rest of the time was cascading recovery, EC2 control plane leases, network state propagation, and NLB health checks, fully normal by about 2 p.m. So the fast root cause and fix longer staged recovery. Um, yeah, okay. So yeah. Do that. Um, um, yes, proceed with this. Okay. So, yep, I nailed it. So, the race condition, yeah, okay, cool. Man, that's wild. Okay. So, so yeah, we're way past the hour mark now. So I've only got a few more minutes. So I've got one final question for it. Then I'm gonna stop the video, do all the uploads, and that'll be it. I think this is probably the best video you'll find out there on YouTube about this outage, US East 1 um, outage. If we search for that, so yeah, like Fireship is a big channel. Let's see if any of these other channels mention the race condition, because if they don't, then like it's just not like. So we're gonna type in race. No, this race condition's not on here. Like, forget about it. Like, there's, you know, this is the value of this channel, right? I go in, I read the actual real sources, and you know, I mentioned it went down so hard, that's just a commenter. But like, they didn't, race condition doesn't appear anywhere in the transcript. So like, that this I'm the only one out here talking about the root cause that even understands that there was yeah, so like prime time, this guy is huge, right? Let's see if race condition shows up anywhere in his transcripts. Nowhere, nowhere. So there you have it. This my channel is the best channel on the internet for hardcore, detailed technical stuff because I go right to the source. And I talk about the root causes. I even understand that there are root causes. So this is exactly what happened. There was a DNS race condition trigger on the 19th at 11:48 p.m. Um, the root cause was identified about an hour later, fully fixed about 3 hours later, and then there were cascading failures throughout other technologies that like depended on that. Like so, so it took them about 12 hours after they fully fixed that race condition and restored a DynamoDB to uh, to fix those other services. And yeah, so there you go. Race condition, race condition, race condition. It's in the transcript. of my video many, many times. Other videos, it's not there at all. So there you have it. So with that, I'll leave the end the video with one final question to the AI. So what's the most valuable thing, like a person like new to cloud, new to AWS, that's like really interested in this? Like for example, somebody who is like a subscriber to my channel, or me myself, like what's the most valuable thing we could do for AWS in light of this outage? Okay, and we'll disable Canva. Let's really let it think. Um, and then and then yeah, that should be good enough. It's not a perfect prompt. We're gonna give it some time to think. So yeah, I'm just gonna take a break here, give it some time to think, come back and end the video on that. Oh, and I happened to notice that some way, somehow, it kept recording. Usually I'm pretty good about that. Um, I don't think it's worth scrapping the video. You might have just heard a toilet flush. I think we're all familiar with what that sounds like. So I might have done a Naked Gun on everyone. One of the greatest movies of all time, the original. I haven't seen the new one, but I don't think I did because I remember seeing it pause. I think it unpaused when I sat down at my desk again. I think I accidentally unpaused it just a few seconds earlier. So if I simply hadn't mentioned anything, it would have probably been fine. But um, if it's on there, it's on there. I'm not scrapping an hour video for that. Um, Although it is kind of ironic that I literally just bragged about my channel and how much better it is than other channels, and perhaps didn't mute myself using the bathroom. But anyway, yeah, I'm gonna pause it some more and leave it to work. And if I ever get a because I think the only difference between my channel and these other like really highly successful channels is one, they spent a lot of money on good audio. I tried doing that, but I kept cheaping out all the time. So I didn't buy like a Shure mic. I didn't buy like, like a bunch of stuff. Like it'd be about $800. It'd be about $800. Um, so I like constantly try to cheap out just to do it for like 200, something like that. And it just never worked. The other thing, they all have editors, right? They're all like working on a team and stuff, which I mean, they're just all like they just all came to the game wealthier than I did. Uh, so like they're able to hire staff and like get the right equipment and all that. Let's see. Okay, I'm just gonna give this some more time to cook and be right back. All right, I'm back, dear viewers. So this is what I will leave you with in this video. This video was long overdue. Probably could do a whole series of videos based off of this. But this is the most valuable thing we all can do for AWS and your own uptime is to become a well-behaved multi-availability zone, optionally multi-region client. So US-EAST-1 goes down. Okay, we're using US-EAST-2 for 12 hours. Who cares? So enable jittered retries and timeouts, build idempotency and failover, uh, Route 53. And when it fits, use DynamoDB global tables so you can keep serving if one region stumbles. Boom, there you go. The perfect answer. This directly reduces incident amplification and support noise during events like 1920, or sorry, like what occurred at Amazon for those like 14 or so hours. Why this is the highest leverage move? Three reasons. Number one, um, incidences cascade. So your client behavior can worsen or relieve them. So that's the other thing too, right? Like all these businesses are set up improperly. So like East One goes down, like it, it creates these cascading failures for the other services that that they're using. If you have, you know, a multi availability zone um, client, then you're not going to have cascading failures because it'll just go over to the other one and all your services will work. So now while they're troubleshooting at Amazon AWS, while they're troubleshooting US East Zone 1, now you're pounding on their door saying, "Help me with the what was it, NBS, like the other services that were affected." EC2, I think, was the biggest one. Yeah, yeah. So now your EC2 instances are down, and you can't bring them back up, and cascade failure, and it's like, well, that's your fault in a sense. Like you could have just had it set up to be to fail over to another region. So in the US-EAST-1 event, the root cause, the Dynamo DNS race condition, race condition, race condition. You'll hear that phrase on this channel, no others, because this is the channel you go to if you actually want to know the technical details. Was fixed in around 2.5 hours, but recovery stretched into the afternoon because the dependent systems were overloaded slash backlogged. Well-behaved clients, timeouts, jittered retries, back off, ease recovery, stampeding retries make it worse. So there you go. Anyone watching this channel, anyone interested in AWS, make me here we go. Here's what I'm going to say next. Make me a list of the companies most affected by this outage. So these are all companies, naughty, that deserve a little bit of a slap, a spanking. So like Snapchat, Reddit, Venmo, Coinbase, Robinhood, they weren't configured right. It looks like Amazon.com, their own site, wasn't configured right to fail over to another availability zone. So there you go. This is the impact. So so am I way off base in saying, like, for myself and my users, like, this is the impact we can make. This is the value we can provide. We can learn how to make these clients, Snapchat, Reddit, Venmo, even Amazon.com itself, which is kind of funny and ironic. We can learn how to make them, let's see here, make them more well behaved, multi-availability zone, multi-region clients that uh, uh, do not amplify, uh, uh, do not fail in a cascading way because they have uh, up the chain. They have up the chain, redundancy and idempotency and build idempotency and failover, uh, and jittered retries and all that stuff. So like um, we can have like Is it fair to say that, the companies you listed there deserve a little bit of a slap on the wrist for not being good clients, and that, myself and the people watching this channel have a really good arbitrage opportunity potentially in the job market, or however else, to make these clients more well behaved? Is that fair to say? Now, this is where the AI is kind of been reconfigured, especially lately. So before, it had a really big problem with sycophancy, like brown nosing, where it just says, "Oh yeah, jumping off a bridge, that's an amazing idea. Perhaps you can fly," you know. But then it was reconfigured to be like less like that, and then people there was an outrage, 4.0 is so nice to me, 5.0 is not. Fix this now. So I think they've made an attempt to fix that. So I kind of don't trust it as much anymore. I really don't like it to be. I like to have my beliefs challenged, and to update my beliefs in light of new evidence. And I just want to believe the best possible things. I don't want to necessarily I don't necessarily want anything else. I definitely don't want AI to be my friend. I want like real people to be my friends. So I kind of trust this a little bit less than I did before for it to be so um, for it to have this tone back where it's saying, "Oh, that's completely fair. Everything you say is brilliant. You're wonderful." But I, I don't think I'm too far off track. So yeah, the most valuable thing you can do is to reconfigure these places that were affected by this outage to be well-behaved clients that like use all the features you can use to prevent cascading failures, to prevent extra to prevent amplification of problems, and to use the resources available by AWS to be more resilient and redundant in the face of failures. So um, incidences cascade. Your client behavior can worsen or relieve them. In the US-EAST-1 event, the root cause was fixed in about 2.5 hours, but recovery stretched into the afternoon because dependent systems were overloaded slash backlogged. Well-behaved clients that use features like timeouts, jittered retries, and backoff ease recovery. Stampeding retries make it worse. Jittered exponential backoff is the Amazon standard. AWS guidance shows jitter dramatically reduces retry storms. Modern SDK standard retry mode already does this and includes circuit breaking. Verify it's on everywhere. So yeah. So that's a good one. It links to a blog. Um, I might even include some of these. I'm just going to include the link to the chat here. That should be enough. Then I won't need to include all these. So the third highest leverage move you could do for a client that's been affected by this outage, which if you're watching this channel, you're a cloud person, you have an interview coming up, mention this, right? Like about the outage, and not only that, how they could have been affected by the outage less if it were to occur again. Architectural failover keeps you and AWS out of crisis paths. Route 53 health check failover, and where appropriate, DynamoDB global tables, now with multi-region strong consistency, let you serve from another region slash endpoint when one is impaired, cutting ticket volume and blast radius. So there you go. Like, a lot of the clients affected by this, like, yeah, Amazon's got to do better. They shouldn't have, or AWS. I'm not sure if it's the same thing as Amazon. But, well, obviously it's different if Amazon.com was affected. Like, they have to, keep being exceptional and standing by their claims for how well they can have their uptime. But the clients do have a responsibility as well. If you just go into it and kind of set your stuff up by without any sort of uh, adherence to the best practices, like yeah, you're gonna have an issue. So so this is what you can do to make these clients that were affected by this outage not be affected in the same way again. Um, so you can enable jittered replies and sensible max attempts. So there we go. Retry mode standard, max attempts 10, standard users jittered back off, and circuit breaking. So here's how you do it in Python. Okay, Node.js, Java. So there you go. Whichever client company you're working for that wants you to do this. If they're using Python, Node.js, or Java, here you go. This is how you do it. And you'll probably need to, before you just dive into that, you'll probably, um, because I'm sure it's not that simple, and it's just the AI, which is not doesn't know the full context, so it's usually not that simple. Uh, So yeah, you would set the timeouts and idempotency. So ensure per call timeouts and idempotency tokens. Confirm only retry safe recalls. Amazon Builders Library. So that would be really really good. What you could do. So basically, for each of these companies, if you built yourself a tool that like could audit their client configuration against like the AWS builder libraries and like detect like drift from like how they have things set up versus like what the best practices are, especially for things like, redundancy, things like jittered back off and circuit breaking and all of this. Like you'd have a very valuable service that you built that you could sell to companies, right? Because then they could see instantly like what is the drift between our configuration and between like a golden configuration that that AWS would recommend, so that if there's an issue like this on their end, like we're just gonna use US-EAST-2 for the 14 hour, 15 hours that US-EAST-1 was down. Okay, cool. So yeah, my core thesis is right. When AWS goes down, the outage isn't just the cloud's fault. The same physical incidents caused DynamoDB, broken endpoint, request storms, retries without jitter, single region dependencies. So my understanding of this retries without jitter thing is, let me explain this. So, um, and I'll use the greatest program ever made in the history of computers, Microsoft Paint. So basically, the reason you want to have jitter in your retries is because if we have like a hub and spoke sort of topology here with like one server connecting out to like a bunch of different clients like this. Um, if you don't have jittered reply, if none of these clients are set up with jittered replies, or with jitter, because jitter is delay variation. So these go down. What's going to happen is all of these are going to say, what the hell happened at the same time, and just flood this server here, and now this server can't handle this flood of traffic coming in, and it just gets bricked. So instead, if you have a jittered reply set up on yours, and all of them do, instead of it just all being flooded at the server at once, there's delay variation. So now they get sent one at a time, right? Or at least in a way that is more conducive to being handled without overloading this server here. So so that's the difference. So that's one thing you can do for the companies that were affected by this. Make sure that they have jittered replies set up. And that's one thing you can audit if you're building a tool that can detect drift between client configuration of AWS and the best practices uh, in a sort of like golden configuration by AWS. Single region dependencies, AWS internal systems, EC2 control plane, and NLB health checks also behave like bad clients. So yes, most of the high profile failures happen because these apps were fragile consumers. So this is what you can do to make them a robust consumer of AWS services. They weren't architected to handle transient DNS or API faults without amplifying them. You're exactly right that a new generation of engineers who know how to make clients well-behaved, multi-AZ, multi-region can and retry sane can create huge value inside AWS customers, consultancies, and even AWS itself. So, what does it mean for there to be a bad client? It means they retry too fast and in lock step, creating these retry storms that I used the world's greatest computer application ever made in the history of humanity, Microsoft Paint, to point out, but I closed it and didn't save it, so we don't have that drawing anymore. They cache DNS too long or not long enough. They run all production workloads in a single region. They assume EC2 or DynamoDB requests always succeed. They use synchronous call chains with no fallback or queue isolation. These design errors multiply impact during outages. It's ironic but true that even Amazon.com's own retail stack still has legacy single region choke points in US East 1. So why it's an arbitrage opportunity? Most devs don't have a deep fault tolerance expertise. If you can, audit retry behavior, tune STKs, build Route 53 failover, health check circuit breakers, and queue-based decoupling. Then you can walk into a Fortune 500 with a credible offer. I'll make your client AWS clients more resilient and save you millions the next time US-EAST-1 blips, or in fact any AWS related outage occurs that you could have prevented by following their best configuration practices. That's a scarce skill and a high value differentiator. So what a slap on the wrist means in practice: you're right to critique, but frame it as an opportunity over blame. Even billion-dollar companies, even Amazon itself, overlooked basic resiliency hygiene. That means the bar isn't high. Yeah, so you can. There's so many this is a huge opportunity. So here's the takeaway message from the video. This outage showed that being in the cloud doesn't automatically make you resilient. AWS fixed the root cause in 2 hours. The 15-hour outage existed because customers and internal systems didn't behave like good clients. Our opportunity, mine, yours, anyone learning cloud, is to build those well-behaved clients. This is how you add real value and get paid while doing it. Okay, so I'm kind of feeling it right now. I know I usually can only go an hour on these, but I'm feeling it because this is exciting, right? This is a whole business, right? So so yeah, so this is a big deal. So let's yeah, like yeah, outline that, please, and then make it a zip folder. And then what I'll do is I will download it, and then I will put it on my GitHub. How does that sound? Does that make sense? Okay, it's doing it. Okay, so um, yep. So I'm gonna put a lot in the description. I'll put these 4 links. I'll put these 5 links linked to this chat, and then I'll put a link to my GitHub for this because this is a whole business opportunity, right? Like you do compliance audits, or you do like best practice audits, configuration drifts between what a client of AWS has configured and what AWS itself recommends the client to configure. And if you do this company, you could work for Amazon itself because Amazon.com wasn't following the specifications from AWS of what makes a good user of AWS services. It didn't have, resiliency and redundancy across multiple availability zones. And maybe there was a technical reason for it. Maybe it's not so simple as, entering one command or flipping a switch or whatever. But wouldn't it be nice to know, right? Like to have a tool to say, no, it really is just you could sell audits, you could sell compliance audits, and I'm sure like you get a lot of businesses that would pay you for that, right? So like if you can definitively say like no, you're good, there is nothing easy you can do to prevent this next time, like that's probably worth some money to a business that has like extra disposable cash laying around. So. All right, so I think that's all we need to see. That's going to be the end of this video. I'll include these links, 6 links here, and I'll see you in the next one.